Welcome to all. Now I will start questions. See, tricky questions or logical questions are over. More questions. Slowly I will go in order. See, question 7. A block weighing 600 Newton, see, weight 600 Newton, is placed on a rough horizontal surface. See, this is horizontal surface, rough. It is found that the block is on the verge of moving when a horizontal push of 240 Newton is applied to the block. That means, see, they applied a horizontal push. Doubt will come, right side or left side, anything will do. If you apply from this side, it will be pushed to right side, or if you apply from this side, it will push to left side. Both will give same answer. Usually in a question, if it is not given, understood that, and not understood, usual tendency is what? Push means you show like this, see. Nobody will go and show this way. Natural tendency, what? Push, okay. This force of 250 Newton. Now, when you apply this 240 Newton, see, push of 240 Newton is applied to the block. Find coefficient of friction for the contact surface. They want to find the value of mu. So put the sketch here. No reaction, nothing. Let mu be coefficient of friction for contact surface. Now onwards, remember, earlier questions all, frictional force, I have shown red color. No. Now onwards, what I will do is, unknowns, I will use red color, so that it is easier. See, which are known, no red color. Whenever I write something unknown, it is red color. Okay. Let mu be coefficient of friction for contact surface. Now, as usual, let R be normal reaction on the block from the contact surface. See, 1 minute now. After some 2 or 3 more problems, these statements all I will dictate. I cannot write each and every question statement. People who come to the class little later, they will tell nothing is explained. I will tell go back to earlier classes. Okay, then since, see, they told what? When you apply 240 Newton, they told the block is on the verge of moving. Therefore, since the block is on the verge of moving, the resisting frictional force, that is FF, will be corresponding to limiting static friction case, that is called FF limit. I told you, whenever the body is on the verge of moving, it is called limiting friction, FF limit. Okay. FF limit equal to mu into R. See, R also is unknown at present, so R. FF limit standard, so therefore consider equilibrium of the block. See here, weight down 600. Normal reaction R. Observe correctly here, see. I slightly shifted R. Last time I told you, if the block is moving that side, see, slightly more, what will happen? The contact surface will get little higher pressure on that side, see, this way. So, normal reaction will slightly shift. Suppose you write exactly in line, nothing to worry, because sigma m you are not using. But if you are using sigma m, then you should be careful. One puzzle given last time, I solved it. Okay, now start. So this is 240 Newton. FF limit is mu R. This way. One more thing you write here. See, you write one more. I won't write here. You write one more statement. Space is not there. Since when you apply 240 Newton force, the block is on the verge of moving to right side. Therefore, resisting frictional force FF will be to left side. This is every class I can't tell. In what direction you mark what? In what direction you intend to move the block, resisting frictional force will be always in the direction opposite to that one. Okay, now, by chance, you make a note also. If the 240 is this way, see, if in the question, suppose somebody takes 240 this way, the block is on the verge of moving left side, frictional force is right side. Or, I told repeatedly earlier, frictional force will acting on the block when you consider equilibrium is always in a direction opposite to the direction in which that body tends to move. So here, body tends to move right side, so frictional force left side. Okay, now R. Sigma F, see, always show X, X, Y, Y. Okay, that is our question. Our case, we take horizontal x-axis, vertical yy. Sigma Fy0 upward positive. Plus R minus 600 equal to 0. R will come 600 Newton plus. Sigma Fx0, see usually sigma Fy first is better for friction chapter. Sigma Fx0, right side positive, see, minus mu R plus 240 equal to 0. R we already got 600 Newton. Substitute that value, substitute here, you will get mu equal to 0.4 over. So we got the answer right here. In the question they asked us coefficient of friction mu, we got it. Now make a note. Make a note. By chance, I will dictate here. Next question is that only. By chance in the question, they ask you not coefficient of friction, they ask you angle of friction. Even then, you first find mu only. Once you get to mu, you continue further, write what? We know that coefficient of friction, see, we know let phi be the angle of friction. Then we know that tan phi equal to mu or phi equal to tan inverse mu. Substitute mu equal to 0.4, you will get 21.8014 degrees. Okay, you make a note. Very simple question over. This way, I will keep on solving for simple question. Actually today, being Sunday, see, you are seeing this class on Monday. Tomorrow is, because I'm uploading night time, you will get morning. Earlier I used to upload every day at 6 p.m. Now I decided to make it to 8 a.m. Starting of the day is better. So you are seeing it, when you are seeing this one, it will be broadcast or published at 8 a.m. in the morning. That is tomorrow, Monday. But today being Sunday, I had a lot of classes. So today I will limit to just 2-3 questions. It's a small class. Next class, I will go for more and more questions. Okay, now I will go for question 8. Question 8. As usual, see, these are all very simple questions. Therefore, nothing, I need not write in front of you. Simple questions. So I will write and explain. Now, question 8. You take this as independent question, but I used almost same data because something I want to tell at the end of the 3 questions. Okay, see, same question type, but you take independent. A block weighing 600 Newton is placed on a rough horizontal surface. It is found that the block is on the verge of moving when a horizontal pushing force, see, once again pushing force of 240 Newton is applied at an angle of 16 degrees with horizontal. Last question, they applied 240 horizontally. Your mu came 0.4. Now you are applying 240 little inclined. I told you, if you apply inclined pushing force, rubbing is more, friction, what? It will create more rubbing effect, therefore difficult to move. But since it is moving, means compared to last time, surface is not as much rough as last time. If it is as rough as last time, then horizontal push of 240, see, last time question, mu is 0.4. If same roughness is there, horizontal push of 240 will move it. Inclined, you require more effort, but same effort is found. Independent question. That means surface is slightly, compared to last time, it is little smooth. Okay, you solve the question. Okay. Let this time, see, they do not want, what they want? They want to find angle of friction. So what you do? Right, let phi be angle of friction. Make a note here. And mu be coefficient of friction for contact surface. Then you know mu equal to tan phi. Now something in the class I will tell. In any question in future, I will tell only once. If they ask coefficient of friction, take mu as unknown. Okay. By chance, if they ask angle of friction, you write mu equal to tan phi. You write that one. Let phi be the angle of friction. Write mu equal tan phi. Therefore, even if they want, don't write tan phi there. Even if they want angle of friction, you first find mu only. After finding mu, see the last step here, you find mu. Last step is phi equal to tan inverse mu. So whether they ask mu or whether they ask phi or either they ask coefficient of friction or angle of friction, you for the solution, when you write free body all, you always mark mu. Get the value of mu. I told already. Okay, over. Let R be normal reaction on subblock. See now, slightly shifted here, 240 inclined. For your benefit, if you take 18-degree angle with horizontal, see, blue color I am using only for resolution. See, component this way, component this way. This is cos, this is sine. That is only for your information. See, I should not write it. See, this is cos, this is sine. If you resolve. Okay, you see to make you more clear. Okay, now start. Sigma, free body already told you, since the block is moving, you are pushing this way means it will move right side. See, same statement you write here. After all the statement, that for 240 Newton will create movement or motion to right side. Frictional force will be to left side. Okay, start. Sigma Fy 0. As usual, xy plus r minus 600 not over plus r minus 600 minus 240 into sine 18 equal to 0. Therefore, your r will come. R will come 674.164. See, now r came little more than last time because 600 is pushing, even 240, its vertical component also is pushing the surface. Little more rubbing will come now. Okay, r came. Sigma fx 0 minus mu r, right side positive, minus mu r plus 240 cos 18 equal to 0. Substitute r equal to 674.164. So minus mu into r plus 240 cos 18 0. Your mu will come 0.3386. You got the answer. But in the question, they asked you angle of friction. So next write. Already written here. See, let phi be the angle of friction. We know that angle of friction phi equal to, see, I wrote here mu equal tan phi. So angle of friction phi equal to tan inverse mu, phi did 18.706 degrees. Okay, now question number 9. I write now only. See, 9. New question. A block weighing 600 Newton is placed on a rough horizontal surface. It is found that the block is on the verge of moving when a horizontal not pushing, horizontal pulling force of once again 240 Newton is applied at the same angle. You take independent question. Don't mix up. For see, when I am teaching, I should try to save the time. You should not write same thing. Each time a question is given, you make habit of making independent. Okay. Find, this time I'll ask you simple reason with horizontal. See, what is, find the why waste energy. Find coefficient of friction. Find coefficient of friction. Okay, mu sufficient. We won't waste time in future. Okay, start. This is not required. Now they told block is on the verge of moving right side when pulling force. So therefore what you do now? So now you should pull it. See, this is called push. This is called pull. But they want to pull of how much? 240 Newton at an angle of 18 degrees they told. Okay. Once again, right, let mu be coefficient of friction. This is not required. Why? There is no need of any mentioning phi now. Okay, right. Let R be normal reaction. Then as usual, write all the statement. It is being pulled to right side, frictional force is left side. But one thing now, when you write free body of the block, what happens? Tell me. You should show 240 this side. See how much here? This is your 240 Newton at an angle of 18 degrees. So when you resolve now, what will happen? See there? When you resolve now, where is the green color? where I kept green color. Okay. When you resolve here, see, right side component and upward component. This is horizontal component cos, this is sine using pencil. Okay. Start. Solution. Same question once again. Sigma Fy0 upward positive plus R minus 600. See now, not minus, plus 240 sine 18 equal to 0. Your R will change. This time your R will come less than 600 because this upward component of 240 will slightly lift the body, so pressure will be lesser. See, this all I told you earlier. So anyway, calculate. But independent question, don't compare. 600 minus 240 into sine 18 is 525.835. R will come 525.835 plus is not required, okay, plus 525.835 Newton. Now, sigma Fx0, take right side positive, minus mu R plus 240 into cos 18 equal to 0. Or substitute R equal to how much? How much you got here? 525.835 Newton. Black color because now it is known. Minus mu into normal reaction. How much? 525.835 plus 240 cos 18 equal to 0. This is not required. Your mu will come this time. What? Last time it came lesser. Now mu will come more. Why more? Logically you think it here. 240 into cos 18 equal to divided by 525.835. Mu equal to 0.4341. Mu equal to 0.4341. That is the answer. 0.4341 is the answer. Now, today's class, little feeling tired because of Sundays always have more classes. And today I went outside also and lot of driving was there. So I will close this today's class by question 10. Some important logical question. I will write the question and explain. Last question for today. Next time onwards I will do more questions. Question 10 is little interesting question. See, academic point of view, such questions are rare. But competitive examination, such questions are asked, where you have to think a little. See, question. A block weighing 6 kilonewton is placed, now not Newton, kilonewton given, is placed on a rough horizontal surface of coefficient of friction 0.45. So mu is 0.45. Okay. Now they are telling a horizontal force of 4 kilonewton, see it is shown in the figure, 4 kilonewton is applied as shown in figure. Means this way they are applying a force of 4 kilonewton. Then check whether that 4 kilonewton force will move the block to left or not. See, when you apply a force of 4 kilonewton here, tendency is to move the block to left side. Now they want you to check whether the block is in equilibrium at rest or on the verge of moving or it is moving. That is whether that 4 kilonewton will result in motion of the block to left side. Okay, that is the first part. Then second part is there. If the block moves to left, see, you check whether the block will move to left or not. If not, question is over. Second part is not applicable. See, they are asking, you check something. See, check is it safe or not. Then they will tell, if not safe, do something. Okay, if safe means keep quiet. See, you find whether the money in your pocket is sufficient or not. Second part, if not sufficient, I will give you more money. Okay, that means if it is sufficient, you don't require more money. Second part is not valid. Okay, write a note. Second part is valid only when the block will this 4 kilonewton will move the block to left side. So what is the question? If the block moves to left, find what least force is, horizontal force is required to prevent it from moving. Now they want to prevent it. See, if it is not moving, question is nonsense. Suppose the answer is not moving, then no preventing. See, if he goes, you ask him to sit there. Some police station, inspector will tell, see that person is sit there, does not move from there. Then, if he tries to move, prevent it from moving, prevent him. If he simply keeping quiet, don't leave it, not applicable. Okay, class, to check, now class, first you do one thing, write a note here, first part of the question. First part of question. To check whether that 4 kilonewton force will move the block or not. How to check it? Ignore that 4 kilonewton. Don't see 4 kilonewton. Instead of 4 kilonewton, you apply a force P. See, ignore the given force of 4 kilonewton and find what force is required so that the block is on the verge of moving. See, very important. Find what force is required when the block is about to move to left side. Let P be the force to left side. That is, write a note here. That 4 kilonewton gone, replace that one by P. Here, see. When the block is on the verge of moving to left side. Now, I told you, every class I cannot tell, you should write. Therefore, since this P is the force which will to be applied when the block is on the verge of moving, this is a case of FF limit equal to mu into R. You should write all these things equal to mu into R. In the question given, mu equal to 0.45. Therefore, your FF limit, if you don't write, you are losing, equal to 0.45 into R. R is unknown. See, R right here, where R is the normal reaction. Write it. See now. Weight of the block. Now consider equilibrium of the block. See, weight acting down. How much? 6 kilonewton. Normal, now it is moving this side, so normal reaction will slightly shift this side. Okay, I puzzle. Since the P will make the block to on the verge of moving to left side, frictional force will be right side. This FF, this is your FF limit equal to what? It is mu into R. See, mu into R. Already told, equal to mu is 0.45 into R. Okay, now do one thing. Start. As usual, show somewhere to them. See, write somewhere, anywhere. XX and YY. You have to always write it. Okay, start. Sigma Fy equal to 0, take upward positive. Plus R minus 6 equal to 0. Therefore, R equal to plus 6 kilonewton. Okay, then sigma Fx0, take right side positive. You get what? Plus 0.45 into R, then minus P is unknown now. See, minus P equal to 0. Substitute R equal to whatever you got, 6 kilonewton. You get plus 0.45 into 6 minus P equal to 0. Therefore, find the value of P in kilonewton. Plus will come. 0.45 into 6. Into 6. What is this calculator doing? 0.45 into 6 equal to 2.7 kilonewton. It is 2.7 kilonewton. Okay, now do one thing. I will dictate, you should write. See, those people who study from me, in the notes all I will write it, but in the class, some effort required from you. You don't expect me now onwards to write each and everything on the board. I am teaching, doing a service here. So if that much effort you are not putting, don't continue my class. Okay, right? P is 2.7 kilonewton. See now, verdict. See now, what I am telling. Write everything. Therefore, the block is on the verge of moving to left side when the horizontal force to left side of 2.7 kilonewton is applied. Means if we apply any force more than 2.7, see at 2.7 it is on the verge of moving. If we apply any force more than 2.7, the block will move. Okay, now continue statement. But actual applied force is, you should write there. I told you be serious. But the actual applied force is 4 kilonewton, which is more than 2.7 kilonewton. Therefore, if the 4 kilonewton load is applied, surely force is applied, surely the block will move to left side. Right here. Therefore, due to the given 4 kilonewton force, the block will move to left. Okay, now over. First right here. First part is over. Right here. First part of question is over. Question is over. Now come to second part. See, now do one thing. Come to second part. See how to solve second part. See, I'll remove this one now. Second part. This all I'll remove. Okay. Actually, somebody will be knowing the answer now. Okay. This also I'll remove. I'll remove everything now. The verdict is what? Block will move. Okay, now. Second part. You write here. Second part of the question. Second part of question. Extension. See, right here. Second part is applicable only if that 4 kilonewton will move the block. See what they want? If the block moves to left, find what least horizontal force is required to prevent it from moving. Now the force is 4 kilonewton. That P is gone. See, what least horizontal force is required to prevent it from moving. That means, right here, that means what? That is what? Apply that 4 kilonewton, apply that 4 kilonewton and 4 kilonewton due to which 100% the block will move. Block will move to left. Now, to prevent that motion to left, apply what they want. Once again, they want horizontal force. Apply unknown horizontal force. See, red color. Unknown horizontal force. Unknown horizontal force. Say, don't call P, I will call P dash. Unknown horizontal force, say P dash. Unknown horizontal force, P dash. And so that P dash will just to prevent the motion. That is, once again, FF limit once again. See, why just to prevent? Because least force required. Right, once again right here. See, remember, the second part is not applicable if your answer of P comes more than 4 kilonewton. See, when you solve the question first part, your applied force is 4. Suppose to move the block, you require a force of more than 4 kilonewton, then due to 4 kilonewton, block will not move. Second part is not applicable. Okay, now, once again, consider equilibrium. Now this time, you apply that 4 kilonewton here. And this is a common sense. Ask somebody on the road. See, if I apply a force this way, the block will move to left side. How to prevent it? Horizontal force. Somebody on the road will tell you apply a force in the opposite direction. See, opposite direction. Say P dash. Then once again remember now, even, see, now note here, even this P dash will, that's very, very important, you write here, that P dash will just to prevent the motion, or the block is still on the verge of moving. Next class I am giving one more question. I will ask you what force will move it to right side. That is something else. Then you have to increase that is next class question. So that P dash will just to prevent the motion. Tendency of 4K2 is to move to left side. This is preventing it. Actually, this is helping the friction. Friction is not sufficient. It will tell, I am there to help you. So even now, frictional force is right side. Same frictional force. Okay, start. Once again. Sigma Fy0. What you get? Plus R. Actually, somebody will tell, sir, I know the answer. How much? Sir, applied is 4. What is the last time answer? I forgot it. What was the last time answer? 2.7 kilonewton. Sir, 1.3 kilonewton. Good. Good. See, objective question, that's all. If it is the objective question, you don't write statement. See, they are applying 4. Okay, then block will move when the force is 2.7. But they are applying 4. Therefore, what you do? So, 2.7, 4. Apply another 1.3 from this side. Prevent it. That's all. But here, solve systematically. Plus R minus 6 equal to 0. Therefore, your R equal to plus 6 kilonewton. Plus 6 kilonewton. Okay. Then, sigma Fx0. Right side positive. See now, mu 0.45 plus 0.45 into R plus P dash minus 4 equal to 0. Substitute R equal to plus 6 kilonewton. You get 0.45 into 6 plus P dash minus 4 equal to 0. Your P dash will come surely plus 1.3 kilonewton. I will tell you one more thing now. See, not required. 0.45 into 6 is so much. Subtract from 4. 1.3 kilonewton. Over. So answer is 1.3. See, now force is 4. 0.45. Okay. Now question is over. One extra information. See, applied force is 4. Maximum frictional force limiting is how much? 2.45 into R is 2.7 kilonewton. So, when you apply 4 here, friction can resist maximum 2.7. That's all. Some help required for friction. So, help the friction by applying how much? Another 1.3 kilonewton. This 1.3 and 2.7 together will balance the force of 4 kilonewton. So simple to understand. Okay, that's all. Today's class I am concluding. Next class I will do more questions. Okay, we'll meet next time. Thank you.